We're going to pick this one up right where we left off. We were in the midst of a pretty complicated problem where we want to graph f of t equals 4 sine 3t minus pi. We saw that we could factor out a t and create this. What we end up with is this double layer of parentheses, because we already had 3t minus pi in parentheses. If we factor out a 3, we get another layer. But then what's nice is we see that value of the phase shift, or the horizontal shift, from that. And I'll show you another way to do it. We'll also have a formula for it if you don't want to factor out. But factoring out will always work. So we had our amplitude period. We saw the phase shift. Now we got to start trying to put a graph together. Now, one technique you can use as you put all these details together is to first draw a preliminary graph. And I like to do this a lot. I'm going to draw a preliminary graph of just y equals 4 sine 3t. So I got the A, I got the B, I got the amplitude of 4, I got the period is the same, but I'm not dealing with the phase shift yet. I'm going to draw a preliminary graph, and then I'm going to use my preliminary graph to incorporate the phase shift and get our function we're really after out of this. Now, in order to do this preliminary graph with my period 2 pi over 3, I need to do what we were doing in earlier calculations. Take the period and divide by 4. 2 pi over 3 divided by 4 is 2 pi over 3 times a fourth. That's 2 pi over 12, or pi over 6. Pi over 6 is going to be what I mark off my horizontal axis in increments of pi over 6. So like pi over 6, 2 pi over 6, 3 pi over 6, and 4 pi over 6. Of course, some of these fractions can be reduced, right? Because 2 pi over 6 is just pi over 3. 3 pi over 6 is just pi over 2. 4 pi over 6 is just 2 pi over 3. That's our period, so we see one period here. Let's see, amplitude is 4, so I'm going to mark 4, negative 4. And this is a sine graph, so I know I start at 0, go up to the high point, back down to 0, down to the low point at negative 4, and back to 0. There's one period, one cycle, right? One period. And again, it's nice if you reduce those fractions in there, and yet don't make this more complicated than it has to be. We're really just taking pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, which is a period, to get our important points. So there's our preliminary graph drawn, but now we got to work on our final graph, which was going to be f of t equals 4 sine of 3t minus pi, where we have now a phase shift that we figured out was pi over 3 to the right. So what I'm going to do is I'm going to take these important points from my preliminary graph. I'm going to take 0, pi over 6, 2 pi over 6 or pi over 3, 3 pi over 6 or pi over 2, 4 pi over 6 or 2 pi over 3. And, sorry, got off to the side. And I'm going to add the phase shift onto each one of those. Okay. So those are, again, those are just the important input values. I'm using the reduced forms here. And when I add pi over 3 onto each one, I get pi over 3. Pi over 6 plus pi over 3. I got to add fractions here, right? That's pi over 6 plus 2 pi over 6 is 3 pi over 6, which is going to be pi over 2. Then I get 2 pi over 3. Then I get 3 pi over 6 plus 2 pi over 6 is going to be 5 pi over 6. And 2 pi over 3 plus pi over 3 is 3 pi over 3, or pi. Okay? So these are the values that I need to mark on my horizontal axis to plot the final graph. Those will reflect the shift. Notice if I compare to the graph up above, pi over 3 was already the second mark. Pi over 2 was already the next mark. And then 2 pi over 3 was the next mark. 5 pi over 6 would come next, because 1, 2, 3 pi over 6, 4 pi over 6. Next would be 5 pi over 6. And then 6 pi over 6 would come next, which is just pi. So those new labelings, really, I'm just jumping one tick mark over from that preliminary graph. And mark 4 and -4. And now I don't want to start at the origin. I need to start here at pi over 3, showing my phase shift. At pi over 2, we go up 1. 2 pi over 3, we come down. 5 pi over 6, we're down at -4. Pi, we're back to 0. All I have to draw is one period of my graph, and there it is. All right, so there's my final graph of this function with the phase shift built in. This is t-axis, f of t here. Now, we're done with the problem, but let's just see now, how can we find that phase shift in an easier way without having to go through so much work? I don't mind doing the double parentheses of factoring. But if you do, I'll give you a formula here. So what we want to do is we're going to start with a formula that looks like a sine bx minus c. We're going to introduce a c constant now into all of this. And if you do that, factoring out to create the double layer of parentheses, you got to take that bx minus c and take the c and multiply by b over b. Okay. Then I can factor out a b times x minus, so this b and this b are replaced. I'm going to have x minus c over b in parentheses. In the inner parentheses, I'm still going to have a sine of all that stuff. Okay. And this double layer of parentheses shows me what the horizontal shift is with the phase shift. The phase shift is c over b. So just like we have a formula for the period, we now have a formula for the phase shift that we're going to be able to use in future problems. So there's our final graph of the function we wanted, along with our formula for phase shift that we're going to be able to use from now on.